The United States entered 1939 with an industrial capacity built over decades, but directed almost entirely toward civilian purposes. Automobile plants in Detroit produced passenger cars. Shipyards along the coast constructed merchant vessels and occasional naval contracts. Aircraft manufacturers operated small facilities, turning out fewer than 6,000 planes annually, most for civilian markets or limited military orders. Steel mills, chemical plants, and machine shops functioned within a peacetime economy that had only recently emerged from the Depression's constraints. The Army numbered approximately 190,000 soldiers. The Navy operated a fleet built largely during and shortly after the First World War. Military procurement followed peacetime schedules with modest budgets and limited urgency. Army Air Corps orders represented a small fraction of total aircraft production. Tank production existed only in experimental quantities. The Springfield Armory and a handful of other facilities produced rifles and small arms at rates sufficient for a small standing force. European conflict began in September 1939. American industries observed but did not immediately transform. Initial responses focused on cash and carry provisions, allowing belligerent nations to purchase arms and equipment. Orders began arriving from Britain and France for aircraft, ammunition, and vehicles. These represented incremental increases rather than fundamental shifts in production philosophy. The fall of France in June 1940 altered calculations. President Roosevelt called for production of 50,000 aircraft annually, a figure that exceeded existing capacity by an order of magnitude. The number reflected political determination rather than industrial assessment, but it established a benchmark. The National Defense Advisory Commission formed to coordinate industrial mobilization. Dollar-a-year men from major corporations joined government offices to bridge military requirements and manufacturing capability. Automobile manufacturers faced conversion first. General Motors, Ford, and Chrysler possessed assembly line expertise, machine tools, and trained workforces. Converting car production to tank or aircraft manufacturing required retooling entire factories. Stamping presses that shaped fenders needed modification for armor plate. Assembly sequences designed for civilian vehicles required redesign for military specifications. Engineers worked through 1940 and 1941 developing conversion plans. William Knudsen, former General Motors president, directed the Office of Production Management starting January 1941. His approach emphasized gradual conversion, allowing continued civilian production while building military capacity. Factories would produce cars in decreasing numbers while simultaneously establishing military production lines. This avoided the complete shutdown that might waste productive capacity during transition periods. Aircraft production presented distinct challenges. Existing manufacturers like Douglas, Boeing, Consolidated, and Curtiss operated facilities sized for pre-war demand. Expanding required not just larger buildings, but trained workers capable of precision assembly. Aircraft construction involved thousands of parts requiring exact tolerances. Riveting, wiring, and hydraulic system installation demanded skills absent from most industrial workforces. The government funded factory construction directly. The Defense Plant Corporation, established under the Reconstruction Finance Corporation, financed new facilities that would be leased to manufacturers. This separated capital investment from corporate balance sheets and accelerated expansion. By mid-1941, construction projects included massive aircraft assembly plants, engine facilities, and component manufacturing centers. Ford broke ground on the Willow Run plant in April 1941. Designed to produce B-24 Liberator bombers, the facility would eventually stretch over 3.5 million square feet under one roof. The concept applied automobile mass production principles to four-engine bombers. Subassemblies would move along a main assembly line with components arriving from feeder lines. The ambition exceeded anything attempted in aircraft manufacturing. Shipyard expansion followed similar patterns, but confronted different constraints. Naval vessels required specialized facilities with dry docks, cranes, and trained workers familiar with marine engineering. Existing yards operated near capacity, fulfilling pre-war contracts and initial naval expansion programs. New construction focused on both expanding existing yards and building entirely new facilities. Henry Kaiser entered shipbuilding without traditional maritime experience. His construction company had built dams and highways using mass production techniques and prefabrication. Kaiser proposed applying these methods to merchant ship construction. The Maritime Commission, seeking rapid expansion of the merchant fleet, awarded contracts. Kaiser's Richmond, California yards would eventually demonstrate that standardized designs combined with prefabricated sections could dramatically reduce construction time. Steel production required expansion but possessed existing capacity. Mills operated below maximum output during the late Depression years. Increasing production meant running existing facilities at higher capacity while adding new blast furnaces and rolling mills. The steel industry coordinated expansion with government oversight, prioritizing types of steel needed for armor plate, ship construction, and structural applications. Aluminum presented a critical bottleneck. Aircraft construction demanded aluminum in quantities far exceeding peacetime production. The United States produced approximately 327,000 tons in 1939. Meeting projected aircraft production required several times that amount. The government financed massive expansion of aluminum production capacity. New smelters required enormous electrical power, directing investment toward hydroelectric facilities and power infrastructure. Small arms production expanded from limited government arsenals to include commercial manufacturers. The M1 Garand rifle, adopted as standard infantry weapon in 1936, required production increases from thousands to millions. Springfield Armory developed manufacturing techniques, then licensed production to Winchester and other firearms manufacturers. Each rifle contained approximately 48 machine parts requiring precise tolerances. Ammunition production involved chemical plants, brass mills, and assembly facilities. Brass cartridge cases came from civilian industries producing plumbing fixtures and commercial applications. Powder production required chemical plants capable of handling nitrocellulose and other explosives. Primer production involved mercury fulminate and lead compounds. Coordinating these supply chains across multiple industries and ensuring quality control presented ongoing challenges. The Lend-Lease Act, passed March 1941, committed American production to Allied support before formal entry into war. Britain and later the Soviet Union would receive equipment directly from American factories. This transformed production planning from supplying American forces to meeting Allied requirements. Specifications had to accommodate British and Soviet needs. Shipping had to be coordinated with convoy schedules and port capacities. Tank production began with limited models and small quantities. The M3 Grant/Lee entered production in 1941. Its design represented compromises between British requirements, American manufacturing capabilities, and tactical concepts. The main 75mm gun mounted in a hull sponson rather than a turret reflected manufacturing limitations and design inheritance from earlier concepts. Production occurred at several locations, including Lima Locomotive Works and Chrysler's new tank arsenal. Chrysler constructed the Detroit Tank Arsenal in 1940 and 1941. The facility occupied 113 acres and employed methods from automobile manufacturing adapted to armored vehicle production. Tank hulls moved along assembly lines with workers installing components at sequential stations. The approach anticipated mass production methods, but required development as techniques were refined. Artillery production expanded from small government facilities to include commercial foundries and machine shops. The 105mm howitzer became standard field artillery. Production required castings, precision machining of barrels and breech mechanisms, and manufacture of recoil systems. Forges capable of producing large castings were identified and converted to artillery production. Truck production leveraged existing commercial vehicle manufacturing. The military required standardized designs in several weight classes. The 2.5-ton truck became ubiquitous. Manufacturers produced to military specifications while maintaining some civilian production. The vehicles used commercial components where possible, but incorporated military features like all-wheel drive and reinforced frames. By December 1941, production remained far below projected wartime requirements, but had increased substantially from 1939 levels. Aircraft production reached approximately 19,000 units for the year. Tank production totaled several thousand. Naval construction included battleships, carriers, cruisers, destroyers, and submarines at yards operating near capacity. Merchant ship construction had begun accelerating under maritime commission programs. The attack on Pearl Harbor eliminated remaining constraints on mobilization. December 1941 marked not the beginning of industrial conversion, but the acceleration of processes already underway. Factories operating partial military production shifted entirely to war materials. Automobile production for civilian markets faced restrictions and eventual cessation. Rubber, copper, steel, and aluminum allocation came under strict government control. The War Production Board replaced earlier coordinating agencies in January 1942. Donald Nelson, formerly of Sears Roebuck, directed the agency with authority over industrial priorities and allocation. The board established preference ratings determining which contracts received materials and components first. Military production received top priority. Essential civilian goods received lower ratings. Non-essential production faced severe restrictions. Labor shortages emerged as production expanded faster than workforce growth. Unemployment, still elevated from depression levels in 1940, declined rapidly. Industries competed for workers. Wages rose. The National War Labor Board managed disputes and established wage guidelines, attempting to prevent inflation while ensuring adequate labor supply. Training programs taught welding, riveting, machine operation, and other industrial skills to workers without manufacturing experience. Women entered industrial work in unprecedented numbers. Propaganda emphasized patriotic duty, but economic necessity and wages drew women into factories and shipyards. Training programs accommodated workers without prior industrial experience. Job classifications were modified to allow women into roles previously restricted to men. By 1942, women represented an increasing fraction of workers in aircraft plants, ammunition facilities, and other war industries. The West Coast received particular attention for expansion. Proximity to Pacific naval operations and availability of space allowed construction of massive new facilities. Southern California became a center of aircraft manufacturing. The San Francisco Bay Area hosted shipyards and naval facilities. The Pacific Northwest contributed aluminum production, aircraft manufacturing, and shipbuilding. Existing plants in the Northeast and Midwest expanded, while new facilities supplemented capacity. Connecticut hosted firearms and component manufacturing. Pennsylvania steel mills increased output. Illinois and Ohio contributed machine tools, engines, and manufactured goods. Michigan remained the center of vehicle production, with auto plants converting to military applications. Quality control presented escalating challenges. Rapid expansion brought inexperienced workers and rushed production schedules. Defect rates in early production ran high. Aircraft engines failed acceptance tests. Ships revealed construction flaws during sea trials. Ammunition lots failed inspection. The military established inspection systems at factories with government representatives monitoring production and rejecting substandard items. Standardization reduced complexity. The military reduced vehicle types, eliminated minor variations, and standardized components. Aircraft models consolidated around proven designs. Ships followed standard patterns with variations only for specific purposes. This allowed factories to focus on high-volume production of limited types rather than small quantities of many variants. Subcontracting distributed production across industries. Major manufacturers designed products and produced critical components, while subcontractors supplied parts. Automobile companies produced aircraft engines. Refrigerator manufacturers made ammunition. Furniture companies built aircraft components. This distributed approach utilized existing industrial capacity while allowing specialized facilities to focus on final assembly. The first months of 1942 revealed gaps between plans and output. Production targets exceeded actual deliveries. Aircraft monthly production remained below 5,000 units, when projections called for much higher numbers. Merchant ship construction continued traditional methods, with individual ships requiring months. Tank production increased, but remained insufficient for equipping expanding armored divisions. Observers from Allied nations assessed American production during 1941 and early 1942 with mixed conclusions. British representatives noted industrial capacity, but questioned whether American methods would translate to military equipment. Soviet officials, receiving Lend-Lease supplies, evaluated quality and suitability. German intelligence tracked American production capacity and projected future output, though assessments varied regarding how quickly production would reach full scale. Technical challenges emerged specific to each production area. Aircraft required aluminum alloys in specific tempers and thicknesses. Welding armor plate demanded techniques different from structural steel. Marine diesel engines required precision manufacturing. Radio equipment needed skilled assembly and testing. Each problem required engineering solutions, worker training, and sometimes redesign a product for manufacturability. Material shortages appeared in specific categories despite overall industrial capacity. Rubber became critical with Southeast Asian supplies cut by Japanese conquest. Synthetic rubber production received crash priority. Copper supplies tightened as electrical wiring, ammunition, and numerous other applications competed for limited material. Aluminum production expanded but remained below requirements through 1942. The machine tool industry faced particular pressure. Lathes, milling machines, presses, and other tools were required to expand every other industry. Machine tool production increased but could not immediately meet demand. Priorities determined which factories received new equipment first. Used equipment was redistributed from civilian to military production. Some facilities operated aging equipment beyond normal service life. Testing facilities expanded to evaluate equipment before deployment. Proving grounds tested tanks and vehicles. Aircraft underwent flight testing programs. Artillery pieces fired thousands of rounds to verify durability. Ships conducted sea trials. This testing revealed design flaws requiring correction and manufacturing defects requiring process changes. By mid-1942, production rhythms began stabilizing. Factories completed conversions. Workers gained experience. Supply chains established reliability. Output increased month by month as mass production reached sustainable rates. The chaos of early mobilization gave way to systematic manufacturing on scales unprecedented in any previous conflict. The Liberty Ship program exemplified standardized mass production applied to merchant vessel construction. The design derived from British tramp steamer plans, modified for American construction methods. The ships measured 441 feet long, with a capacity of over 10,000 tons. Every Liberty ship followed identical specifications, allowing fabrication of interchangeable components at multiple locations. Henry Kaiser's Richmond yards pioneered prefabrication techniques. Hull sections were welded together at separate stations, then moved to assembly positions where cranes lifted them into place. Traditional shipbuilding constructed vessels in place, with workers assembling each part sequentially. Prefabrication allowed parallel work on multiple sections simultaneously. The first Liberty ships required over 200 days from keel laying to launch. By late 1942, average time dropped below 60 days. The Robert E. Peary launched 4 days and 15 hours after keel laying in November 1942 as a demonstration, though this pace was not sustainable for regular production. 18 shipyards produced Liberty ships. Kaiser operated facilities in Richmond, California, and Portland, Oregon. Bethlehem Steel, Todd Shipyards, and other established firms built additional yards. The Maritime Commission coordinated construction, allocated materials, and managed contracts. By the end of 1942, monthly production exceeded 100 vessels. The rate continued climbing through 1943. Aircraft production reached industrial scale during 1943. Willow Run began delivering B-24 Liberators in quantity. The plant employed over 40,000 workers at peak operation. Initial production encountered difficulties with Ford's mass production approach. Aircraft tolerances differed from automobile standards. Early Liberators required extensive rework. Engineers refined processes throughout 1942 and early 1943. By mid-1943, Willow Run produced one bomber per hour during peak periods. Boeing's Seattle facilities expanded production of B-17 Flying Fortresses. Additional B-17 production occurred at Douglas plants in Long Beach and Vega plants in Burbank. Each manufacturer produced identical aircraft from shared plants. Components manufactured at one location fit aircraft assembled at another. This interchangeability extended to engines, propellers, instruments, and weapon systems. Fighter production followed similar patterns. Republic Aviation produced P-47 Thunderbolts at Farmingdale, New York, and Evansville, Indiana. North American Aviation manufactured P-51 Mustangs at Inglewood, California. Curtiss-Wright produced P-40 Warhawks at Buffalo, New York. Monthly production of all fighter types exceeded 2,000 aircraft by mid-1943 and continued increasing. Engine production operated as a separate manufacturing stream. Pratt & Whitney produced radial engines at East Hartford, Connecticut, and additional facilities. Wright Aeronautical manufactured engines in New Jersey. Ford built Pratt & Whitney engines under license at a dedicated plant. Packard produced Rolls-Royce Merlin engines for P-51 Mustangs. Allison manufactured inline engines for P-38 Lightnings and other aircraft. Coordinating engine delivery with airframe production required continuous communication between facilities separated by thousands of miles. Tank production stabilized around standardized models during 1943. The M4 Sherman replaced earlier types as the primary medium tank. Multiple manufacturers produced Shermans from common specifications. Chrysler's Detroit Arsenal, Fisher Tank Division, Ford, Pacific Car and Foundry, Press Steel Car Company, and other facilities built identical vehicles. Monthly production exceeded 2,000 units by late 1943. Sherman production involved casting or welding hulls, depending on manufacturer capabilities. Chrysler used cast hulls. Other manufacturers employed welded construction. Both methods produced functionally identical tanks. Turrets were cast at foundries, then machined for weapon mounting and equipment installation. Final assembly occurred on moving lines with engines, transmissions, tracks, and systems installed at sequential stations. The 75mm gun initially mounted on Shermans came from multiple manufacturers. The same weapon equipped M3 Grant/Lee tanks, allowing parts commonality and simplified training. Later production incorporated 76mm guns with improved armor penetration. Ammunition production for tank guns occurred at separate facilities producing shells, propellant charges, and primers. Artillery production reached high volume during 1943. The 105mm howitzer remained standard divisional artillery. Production exceeded 8,000 units in 1943. The 155mm howitzer and gun equipped corps-level units. Anti-aircraft guns included 40mm Bofors produced under Swedish license and 90mm guns manufactured at multiple locations. Each artillery piece required precision machining of barrels, manufacture of recoil mechanisms, and production of fire control instruments. Small arms production achieved mass scale. M1 Garand rifle production totaled approximately 4 million units in 1943. Springfield Armory, Winchester Repeating Arms, and Harrington and Richardson manufacture Garants. The M1 carbine, adopted for support troops and specialized units, entered production at multiple facilities including Winchester, Inland Division of General Motors, and others. Total carbine production for 1943 exceeded 2 million units. Ammunition production consumed vast quantities of brass, lead, and explosives. Lake City Army Ammunition Plant in Missouri produced small arms ammunition in billions of rounds annually. Additional plants operated in St. Louis, Denver, Salt Lake City, and other locations. Cartridge cases required brass mills producing strip material, stamping presses forming cases, and assembly lines installing primers and loading powder and bullets. Truck production maintained high volumes with limited interference to military needs. Restrictions on civilian automobile production freed capacity for military vehicles. The 2.5-ton 6x6 truck became standard for general cargo. The Dodge WC series served as light utility vehicles. GMC produced heavy trucks, including the DUKW amphibious vehicle. Total military truck production exceeded 600,000 units in 1943. Naval construction continued expanding through 1943. Essex-class aircraft carriers entered service at approximately 1-month intervals. Construction time for these 27,000-ton vessels averaged about 20 months from keel laying to commissioning. Multiple yards built Essex-class carriers simultaneously. Independence-class light carriers, converted from Cleveland-class cruiser hulls, entered service more rapidly, with construction times around 15 months. Destroyer production reached industrial scale with Fletcher-class vessels. These 2,100-ton destroyers could be built in 12 to 14 months. Multiple yards produced Fletchers concurrently. By the end of 1943, over 175 Fletcher-class destroyers were completed or under construction. Destroyer escorts, smaller and simpler vessels designed for convoy protection, entered production with construction times under 1 year. Submarine construction maintained steady output. Gatto-class and Below-class boats, nearly identical in design, came from yards in Groton, Connecticut, Portsmouth, New Hampshire, Mare Island, California, and Manitowoc, Wisconsin. The Manitowoc facility, located on Lake Michigan, transported completed submarines down the Mississippi River to the Gulf of Mexico. Construction time averaged about 12 months per boat. Landing craft production became critical for amphibious operations. Andrew Higgins designed landing craft with bow ramps, allowing direct beach deployment of troops and vehicles. Higgins Industries in New Orleans produced LCVPs, landing craft, vehicle, personnel, and larger LCMs, landing craft, mechanized, and high volume. Additional manufacturers produced various landing craft types, including LSTs, landing ship, tank, large vessels capable of ocean crossings and direct beach landings. The logistics of moving produced equipment from factories to operational theaters required coordination across transportation networks. Railroads moved tanks, artillery, and vehicles from inland factories to ports. Aircraft flew from factories to modification centers, then to embarkation points. The Air Transport Command ferried aircraft across oceans using routes through South America to Africa or through Canada and Alaska to the Soviet Union via Lend-Lease. Port facilities expanded to handle increased shipping volumes. East Coast ports loaded equipment bound for Europe. West Coast facilities handled Pacific shipments. Gulf ports supported operations in both theaters. Each port required warehouses, loading cranes, rail connections, and berthing for multiple ships. Newport News, Virginia, New York, San Francisco, Los Angeles, and Seattle operated continuously with multiple shifts. Replacement rates in operational theaters reflected production volumes by mid-1943. Aircraft losses, whether from combat or operational accidents, could be replaced within weeks. Tank losses were replenished from depots receiving continuous shipments. Artillery ammunition expenditure, even during intensive operations, did not exhaust supplies. This contrasted sharply with earlier periods when losses temporarily exceeded replacement capacity. The Mediterranean theater during 1943 demonstrated these replacement dynamics. The North African campaign through May 1943 saw continuous equipment attrition. Aircraft losses from all causes totaled hundreds per month. Tank losses varied with operational intensity. American units maintained strength through replacement flows from the United States. The Sicily invasion in July and Italian campaign beginning in September sustained high equipment usage. Supply lines delivered replacements, maintaining unit readiness. German intelligence services tracked American production through various sources. Neutral country reports, aerial reconnaissance of factories when possible, and analysis of captured equipment provided data. German assessments by late 1943 recognized American production exceeded German capacity by substantial margins. Specific estimates varied, but the general conclusion indicated American monthly output surpassed German production in most categories. Japanese intelligence similarly monitored American industrial output. Early assessments underestimated production potential and speed of mobilization. By 1943, Japanese analysts revised estimates upward. Capture documents and interrogation reports from American personnel provided specific production information. Japanese military planning increasingly acknowledged American material superiority and the impossibility of matching production rates. British observers maintained liaison offices at American factories. These representatives monitored production quality and coordinated Lend-Lease deliveries. Reports noted consistent improvement in manufacturing quality during 1943. Early production often required modification or repair before deployment. By mid-1943, acceptance rates improved significantly. Equipment arrived in Britain requiring minimal preparation before operational use. Soviet representatives operated similar oversight of Lend-Lease production. Soviet priorities emphasized trucks, aircraft, and raw materials rather than tanks or small arms where Soviet production was substantial. American trucks proved particularly valuable. The Studebaker US-6 2.5-ton truck became standard Soviet transport. Deliveries totaled over 150,000 units during the war. These trucks motorized Soviet logistics, reducing reliance on horse-drawn transport. Aircraft deliveries to the Soviet Union followed multiple routes. The Alaska-Siberia route transferred aircraft at Nome, Alaska, where Soviet pilots took control for the flight to Siberia. The Persian Corridor route shipped aircraft to Iran, then flew them north to Soviet territory. The Northern Convoy route delivered crated aircraft to Murmansk and Arkhangelsk. Each route faced distinct challenges from weather, distance, or enemy action. P-39 Airacobra fighters comprised a large portion of aircraft delivered to the Soviet Union. American forces considered the P-39 marginal for European combat, but Soviet pilots employed them effectively in ground attack roles. Total P-39 deliveries to the Soviet Union exceeded 4,700 aircraft. A-20 Havoc bombers and other types supplemented Soviet tactical aviation. Quality control processes matured during 1943. Statistical sampling methods identified defect patterns. Root cause analysis traced problems to specific manufacturing steps or suppliers. Corrective actions included worker retraining, process modifications, or design changes for manufacturability. Rejection rates declined as these systems identified and eliminated recurring defects. Standardization extended beyond major equipment to components and supplies. Ammunition came in standard packaging. Spare parts used common packaging and labeling. Tools were standardized across services where possible. This simplified logistics and reduced training requirements. Mechanics familiar with one truck model could service similar models from different manufacturers using common repair procedures. Raw material allocation stabilized during 1943. Initial shortages in aluminum, copper, and rubber eased as expanded production came online. Synthetic rubber production reached levels allowing sustained tire manufacturing. Aluminum production exceeded 1.5 million tons in 1943, up from approximately 327,000 tons in 1939. Copper production increased through expanded mining and recycling programs. Labor force size peaked during 1943 in many industries. Turnover declined as workers gained experience and wages stabilized. Union agreements minimized strikes in war industries. The United Auto Workers, United Steelworkers, and other unions maintained no-strike pledges. Disputes went to the National War Labor Board for resolution. Production continuity became possible with stable employment. Women constituted approximately 35% of the aircraft industry workforce by 1943. Shipyards employed women as welders, electricians, and in other skilled trades. Ammunition plants had predominantly female workforces in assembly operations. These workers operated machinery, performed precision assembly, and conducted quality inspections. Training programs typically lasted weeks rather than months, with on-the-job training supplementing classroom instruction. Shifts operated around the clock in major facilities. 3 8-hour shifts provided 24-hour production. Some facilities operated 2 12-hour shifts. Continuous operation maximized equipment utilization and maintained steady output. Shift changes required coordination to prevent production gaps. Maintenance occurred during planned downtimes or on dedicated maintenance shifts. Production bottlenecks shifted as different components or materials became limiting factors. Early 1943 saw propeller production limiting aircraft output at some facilities. Expansion of propeller manufacturing resolved this constraint. Later, specific instruments or radio equipment became limiting. Each bottleneck required identification and targeted expansion of the constraining production element. The Battle of the Atlantic illustrated production's operational impact. German U-boats sank merchant ships faster than traditional construction could replace them through 1942. Liberty ship production reversed this balance during 1943. Monthly launchings exceeded sinkings by increasing margins. By mid-1943, the merchant fleet was expanding despite continued losses. This allowed sustained supply flows to Britain and buildup for European operations. Escort carrier production supplemented merchant shipbuilding. These small carriers converted from merchant hulls provided air cover for convoys. Kaiser shipyards produced Casablanca-class escort carriers using Liberty ship construction techniques. Construction time averaged approximately 3 months. 50 Casablanca-class carriers entered service between July 1943 and July 1944. These vessels carried approximately 27 aircraft each, dramatically increasing available naval aviation. Strategic bombing of Germany intensified during 1943 with increased aircraft availability. The 8th Air Force in England expanded from several hundred to over 1,000 heavy bombers. Replacement aircraft arrived continuously, allowing sustained operations despite combat losses. Monthly loss rates occasionally exceeded 100 aircraft, but replacements maintained force strength. Production capacity absorbed losses that would have crippled forces dependent on limited manufacturing. Pacific operations similarly depended on replacement flows. Naval aviation losses from combat and operational accidents required continuous replacement. Carrier air groups deployed with specific aircraft numbers, then received replacements as needed. Fast carrier task forces maintained operational tempo because damaged or destroyed aircraft were replaced within days or weeks. Landing craft availability determined amphibious operation scale. Early Pacific landings used limited numbers of landing craft, constraining force size and operational flexibility. By late 1943, landing craft numbers increased substantially. The Gilbert Islands operation in November 1943 employed hundreds of landing craft. Artillery ammunition expenditure reached levels unprecedented in previous conflicts. A single divisional artillery battalion might fire thousands of rounds during major operations. Monthly production measured in millions of rounds ensured stockpiles at forward depots. Unlike previous conflicts where ammunition shortages constrained operations, American forces rarely limited fire missions due to ammunition availability. The Italian campaign demonstrated logistical sustainability. From the Salerno landings in September 1943 through the winter fighting, American units maintained equipment strength. Difficult terrain caused vehicle attrition. Mountain warfare damaged equipment at high rates. Replacements arrived through supply lines extending back to North African ports and ultimately to American factories. Units remained operational despite sustained equipment losses. Tank destroyer production provided specialized anti-armor vehicles. The M10 mounted a 3-inch gun on a modified Sherman chassis. Later production shifted to the M18 Hellcat with a 76mm gun and improved mobility. The M36 Jackson, entering production in late 1943, mounted a 90mm gun providing enhanced armor penetration. These vehicles supplemented towed anti-tank guns and provided mobile firepower. Truck-mounted weapons extended firepower mobility. Multiple rocket launchers mounted on truck chassis provided area saturation fire. Anti-aircraft guns on truck mounts allowed mobile air defense. Tank recovery vehicles used truck or tank chassis with cranes and winches. This mobility reflected American emphasis on mechanized operations requiring supporting equipment to match tactical movement rates. Petroleum production and refining supported mechanized operations. Refineries produced aviation gasoline, diesel fuel, and motor gasoline in volumes matching equipment deployment. Tanker construction delivered fuel across oceans. Pipeline construction in rear areas distributed fuel forward. Jerrycan production provided portable fuel containers. Every mechanized division required thousands of gallons daily, supplied through logistics networks originating at American refineries. Communications equipment production equipped command and control networks. Radio production included tactical sets for companies and battalions, administrative sets for higher headquarters, and specialized equipment for artillery and aviation. Telephone equipment included field telephones, switchboards, and wire. Signal Corps procurement coordinated production across multiple electronics manufacturers. Medical supplies production supported casualty care systems. Pharmaceutical production included sulfa drugs, morphine, and various medications. Plasma production for treating shock required collection networks, processing facilities, and distribution systems. Bandages, splints, surgical instruments, and hospital equipment came from civilian medical supply manufacturers expanded to military scale. Clothing and equipment production supplied individual soldiers. Uniforms required textile mills, garment factories, and button and fastener manufacturers. Boots needed leather tanning and shoe manufacturing. Helmets required steel stamping and liner production. Web equipment, including belts, suspenders, and pouches, came from canvas goods manufacturers. Each soldier required multiple complete sets of equipment for initial issue and replacements. Food production mobilized agricultural and canning industries. Rations came in various forms, including canned goods, dried foods, and packaged meals. K rations provided individual meal packets. C rations offered canned meals. D rations supplied emergency chocolate bars. Production volumes reached millions of rations monthly. Quality control ensured nutritional content and prevented spoilage during storage and transportation. By the end of 1943, American industrial production reached stable high-volume output across all major categories. Aircraft production totaled over 85,000 units for the year. Tank production exceeded 29,000 vehicles. Artillery piece production numbered in tens of thousands. Truck production approached 700,000 vehicles. Naval construction launched hundreds of vessels, including capital ships, escorts, and auxiliaries. Merchant shipping construction exceeded 19 million deadweight tons. These production levels exceeded Axis capabilities by substantial margins. German aircraft production for 1943 totaled approximately 25,000 aircraft. Soviet production reached about 35,000 aircraft. Japanese production approached 17,000 aircraft. American production alone exceeded the combined Axis total. Similar disparities existed in other categories, though exact comparisons were complicated by different vehicle types and measurement standards. Production dominance translated into operational advantages visible by early 1944. American forces equipped expanding armies while simultaneously supporting Allied forces through Lend-Lease. Equipment quality improved as manufacturing processes matured. Logistics systems delivered produced equipment to operational theaters with increasing efficiency. The industrial base sustained operations at intensities that would have exhausted forces dependent on limited production capacity. Strategic planning incorporated production capacity as a determining factor. Operation Overlord planning assumed equipment availability for over 20 divisions plus supporting units. Pacific operations planned simultaneous multi-theater offensives requiring hundreds of ships and thousands of aircraft. These operational concepts depended on production capacity that was verified by early 1944 output rates. Industrial capacity had become operational capability, enabling strategies impossible without sustained mass production.